This puzzle is called Scream by AnalyticalNinja. I got it from the Stoker Testing Submission channel of the CTC Community Discord. Let's take a look at the rules. Erratic line. Every set of two adjacent digits along the line must have a different sum. For example, if row 2 column 2 plus row 3 column 1... Okay, must have a different than these two. Okay, so the red, or the pink cells must have a different sum than the green cells. That is weird. This is definitely weird. The AnalyticalNinja did say that this was a new constraint. But this is definitely a weird one. Cells separated by a white dot contain consecutive digits. Okay, so this white dot, let's say this was a 3, this would have to be a 2 or a 4 because, of course, those are the consecutive digits with 3. Cells separated by a black dot have a ratio of 1 to 2. That means one of the two numbers is double the other number. So if this was a 1, this would be a 2. This was a 4, this would be a 2. Whoops, too many undos. If this was a 2, this would have to be a 1 or a 4. I guess that's all the options there are. Usually with a 9x9 there's a lot more options, but not so many options with a 4x4. And that's it. The main thing is just this line and then a little bit of extra, I guess, information to help resolve the puzzle and keep it symmetric. Do not know how hard this is. Probably on the easier side, as with most of these 4x4s, but I'm not sure exactly. I'll put a link to the puzzle down in the description if you want to give it a try. Let's get going. So the first thing that I see, especially given this example, let's put these colors back, that these two digits have to be different. Because let's say this is a 3. If I put a 1 here, I couldn't also put a 1 here because these two, green has to sum to a different thing than pink. So in other words, let's even take out this, green and pink have to be different. Because if green and pink were the same, then this would add up to the same as this. That means that green can't be pink, and green must be up here because it can't be in column 1. And in fact, this must be pink. Because pink can't be green, and pink needs to be in column 1 somewhere. So there's a little bit more. This can't be green. Wait, no, yeah, this can't be green because it's not just... every set is different. So we already have used green and pink adjacent. So we can't use green and pink adjacent along the line again, so green has to be way out here. We don't know... Pink is down here somewhere. I guess we can put the last green in right there, just by, Sudoku. Pink is going to be on the white circle, in one of the two white circles. And down here... Maybe we can just do the same thing, kind of... Okay, let's just remove these last pink. So we know these two... Okay, let's just choose a color for this. Let's just choose blue for this. It doesn't matter. We know it's not pink. We know it's not green. So we can just give it a new color. So this must be blue. That's fine. And then blue is down here somewhere and down here somewhere. Does that actually help at all? My last color for 4x4s is usually yellow, but we have a yellow line. Let's do gray. Hopefully gray is not too similar to the blue. Is that pretty similar? Maybe we could do hot pink. That's pretty similar to the just regular pink. What if I switch this to light pink? I don't know. Sorry. Let's just go with yellow. That's fine. We'll just have yellow with the yellow line. So up here is yellow and pink. We know those are adjacent. Down here is yellow or pink. How can we... Maybe, do we have enough information to figure this out already, and I'm just not thinking clearly? It might just be that I'm not thinking clearly. Okay, actually, yeah, so here's something. So this black dot must have a 2 on it. It's either 1, 2, or 2, 4. Those are the only two options. So one of these is a 2. We don't know which, doesn't matter yet. And also, key is that 3 can never be on a black dot. So 3 is one down here. So 3 must come up here, and 2 must come down here. Whoops, 2 must come down here. So what pair is this? It has to be consecutive digits. So it's either 3, 2, or 3, 4. It can't be 3, 2 because we just put 2 down there. So this is 3, 4. Which means this is 1, 2. Blue and green are 1 and 2. So these are the same. So this is a... No, no, this could be blue. This could be blue. No. Oh, wait a minute. I was just thinking, if this is blue, I think we break the puzzle. Oh, it's the same thing as over here, and I wasn't even thinking. Yeah, it's the same thing as over here, and I started thinking about that at one point, but didn't continue that thought. These two can't be the same color. I guess, yeah, every other digit has to be different. That would have been a good thing to realize earlier on. Every other digit must be different. If these two are the same, then this sum will be the same as this sum because this digit is always going to be the same. So this can't be blue. This must be blue. Makes this a 1, 2. This is a 3 or a 4. And we've already done blue-pink, so this can't be blue-pink. This is different. This must be yellow. This must be blue. Now, how do we resolve this? So we have 3. This must be different than this. So this can't be 2 pairs of 5. So this is either 2, 4 or 1, 3. It can't be 1, 3 though. If this is 1, 3, that makes blue 2, which sums to the same thing here. So this must be 2, 4. Oh, I forgot to finish up the colors over here. Which makes this a 1, 2, 1. Okay, let me just double check, because I'm not 100% sure I got this. 3, 6, 8, 5. Oh, we had 5 guaranteed. That would have been another way to look at it. We had 5 guaranteed way back here. We had blue next to both of these, so we had 5 accounted for. So this couldn't have added to 5, which is what I surmised by looking at these two individually. But I could have also done it this way. So let's go back up here to the finish. Okay, so 5, 2, 4. I don't think I had 4 and 7. Yeah, that was a really cool idea. Does this actually use every? Maybe this would have been another way to attack the puzzle. We have 2, 3, 4, 5, 6, 7, 8. Yeah, which is every combination. We have every combination along this line. We could have looked at the length of the line and determined every combination, or every pair sum in a 4x4 must be along this line. I don't know how we would have used that information necessarily, now that I think about it, but that would have been useful information to know. I guess it would have guaranteed that this would be a 1 and 1, because that's the only way to make 2 show up on the line, and we need that sum. Same with 4 and 4. That's the only way to make that sum show up. So that must have been 4, that must have been 1. That would have been a good thing to realize, rather than a little bit less elegant way of looking at this as it must be a 2 and 4, because 1 and 3 would repeat 4 over here. But that was a really cool puzzle. Yeah, making that work for a 9x9 or just a larger puzzle in general would be hard. I have complete faith that AnalyticalNinja could do it. If you didn't see the aquarium puzzle under pressure, I did it a few days ago, or maybe a week ago, and CTC just did it a couple days ago. It was great, also by AnalyticalNinja, which was a weird rule set, like this one. But it was a great puzzle, so check that one out if you haven't. Thank you very much, AnalyticalNinja, for this puzzle, and thank you all for watching.